graph, you have to calculate the resistance of all the 6 conductors. Slope kandupidichittu. In this graph, you can directly get the resistance by finding the slope, because in the y-axis you have V and in the x-axis you have I. So V by I will give you directly the resistance, but in this graph, they have given I value on the y-axis and V value on the x-axis. So you have to calculate the slope, or reciprocal of the slope will give you the resistance. So calculate for A. What is the resistance of A? 2 by 4. So resistance of A is equal to 2 by 4 is equal to 0.5 ohms. Similarly, find for the others also. Fast. Nitish, Leah, Kirti, Mano, Pratap, Varshita, Shaktivel, fast. Calculate the slope here and the reciprocal of the slope in this case from this graph, and calculate the resistance of all the 6 conductors A, B, C, D, E and F. Fast.
Ma'am, C as maximum resistance, F as minimum resistance, ma'am.
Okay. Now tell me the resistance of each conductor. RB, tell me the value.
1.33 ohm.
1.33 ohm. RC, 2.5 ohm. Then RD, 2 ohms. Then RE,
1.75 ohm.
1.75. 0.75 ohms. Please check your answer. RF, 0.
0.4.
2 or 4? 0. 0.4 ohms. So the least one is RF and the highest one is RC. Done? Now next question. Now lightning is a very good example of natural current. There is an energy of 10 power 9 joule energy transfer across a potential difference of 5 into 10 power 7 volt during a time interval of 0.2 seconds. Note down, energy is given 10 power 9 joules, and this energy is transferred across a potential difference of 5 into 10 power 7 volt during a small interval of 0.2 seconds. Now you are asked to calculate the total amount of charge that is transferred. First one, you have to calculate the total amount of charge that is transferred and the current. Using this information, find the total amount of charge that is transferred between the cloud and the ground. Number 2, the current in the lightning. And number 3, the power that is delivered within a time of 0.2 seconds. Now the total energy transferred, potential energy transferred is U is equal to QV. You will use the formula U is equal to Q into V. In the question, U is given as well as V is also given. Vigneshwaran, are you listening? U is equal to Q into V. Therefore, Q is equal to U by V. Calculate the total charge that is transferred. Use the formula U is equal to QV and calculate the total number of charge that is transferred between the cloud and the ground. After that, calculate the current. I is equal to Q by T. Energy is 10 power 9 joules. Potential difference is 5 into 10 power 7. And the time interval is 0.2 seconds. So use the formula U is equal to QV and calculate Q. Tell me the answer in coulombs. How much coulomb is transferred between 20 coulombs? 10 power 9 divided by 5 into 10 power 7. So 100 by 5, 20 coulombs. Now second part is find the current in the lightning bolt. I is equal to Q by T. T is given as 0.2 seconds. I is equal to Q by T. Saravanan, Navina, Manu, Yash, Sai Rakshana, switch on your cameras. Kalai Selvan, Saravanan, Anshul. Ten to the power 2, 100 amperes. I is equal to 100 amperes. Now find the power delivered in 0.2 seconds. Power is V into I. Power P is equal to potential V into the current that you got. Five into 10 power 9 watts. So it is 5 gigawatts of power that is delivered. 5 giga. 10 power 9 is giga. Got the answer? So the total amount of charge transferred was 20 coulomb. The current that is transferred in the lightning is I is equal to 100 amps and power delivered is 5 gigawatts. 5 into 10 power 9. Now third question. A copper wire of 10 power minus 6 meter square area of cross section, capital A is given, carries a current I is equal to 2 amperes. If the number of electrons per cubic meter, what is that? Number of electrons per cubic meter, number of electrons per unit volume. No, that is current density, not volume density. Electron density small n. What is the formula? I is equal to NaEVD. What is the formula? I is equal to N, where N is number density of electron, capital A, area of cross section, small e, charge of an electron, VD, drift velocity. So what are the values that they have given? They have given you area of cross section 10 power minus 6 meter square. I is given as 2 ampere. Small n is given as 8 into 10 power 28. Calculate the current density and average drift velocity. First calculate the drift velocity. I is equal to capital I is equal to NaEVD. Here all the other values are given. E, value of E you know. So you can calculate the drift velocity. Then once you get the drift velocity, even before that, J is equal to I by A. Current density J is equal to I by A. That you can do directly. Even before calculating the drift velocity, you can calculate current density also. So they have asked you to calculate VD as well as J. Point. No, VD, drift velocity. No, not 2.5. It is 1.56. It is 1.56 into 10 power minus 4 or 15.6 into 10 power minus 5. minus 0.01 into 10 power 1.56 into 10 power minus 4. That is your drift velocity, 1.56 into 10 power minus 4 meter per second. And what about current density, J? 2 into 10 power 6. Tell me with the unit. Ampere per meter square. (1.56 into 10 to the power minus 4 meter per second, and J is equal to now the fourth question. The resistance of a nichrome wire at 0 degrees Celsius is 10 ohms if its temperature coefficient of resistance. Now they have given R naught. What is the formula? When alpha is given, what is the resistance at a higher temperature? RT is equal to R naught into bracket 1 plus alpha into T. 1 plus alpha into T. So they have given R naught. Resistance at 0 degrees Celsius is given as 10. Temperature coefficient of resistance, that is alpha, is given as 0.004 per degree Celsius. You have to calculate the resistance at boiling point of water, which means T is 100 degrees Celsius. Calculate. Yes. Temperature? Difference in temperature. 100 minus 0 தானே, அப்ப 100 தான் வரும். T வர இடத்துல 100. கெல்வினுக்கு கன்வெர்ட் பண்ண வேண்டாம். Directly. 4 degrees Celsius. 14 ohms வரும். You're calculating the resistance.
14 ohms.
Yes, 14 ohms. Yes, ma, 14 ohms. So comment on the result. As the temperature increases, resistance also increases in the case of nichrome alloys. Metals, conductors and alloys, they have a positive temperature coefficient of resistance. When temperature increases, resistance also increases. Now the rod given in the figure is made up of two different materials. One is having a length of 25 centimeter, the other one is 70 centimeters. Both have same square cross sections of side 3 millimeter. The cross section is a square and each side has 3 millimeter. The resistivity of the first material is 4 into 10 power minus 3 ohm meter and it is 25 centimeter long, while the second material has a resistivity of 5 into 10 power minus 3 ohm meter and it is of 70 centimeter long. What is the resistivity of the rod between its ends? What will be the resistivity between the ends where they have joined? How will you do the sum? Suppose you're going to consider it as a system, single system. Now this particular material will have, you have to consider as if it is resistance in series. Resistance in series. Consider this one as R1 and this one as R2. What is the equation for, what is the formula for R? Rho L by A. So R1 will be equal to rho 1 because resistivity changes. L1 by, you need not write A1 because A is common. Rho 1 L1 by A plus rho 2 L2 by A. Then substitute. This is resistance in series. So R, total resistance, will be equal to R1 plus R2. Find the common resistance. Then you can calculate the resistivity. Find the common resistance first. Calculate the total resistance first. RS is equal to R1 plus R2. Hmm. 10 power minus 3. That is side. So 10 power minus 3 square, 10 power minus 6. So 9 into 10 power minus 6 will be the area of cross section. Yes. Calculate the total resistance first. RS is equal to R1 plus R2. Where R1 is rho 1 L1 by A plus R2 is rho 2 L2 by A again. Area of cross section is common for both. 9 into 10 power minus 6 meter square. Centimeter also meter you have to convert. Because they have given in ohm meter resistivity. $1.35. No, not so low. Note down the values, calculate fast.
Ma'am, I see 3.8 into 10 to the power 4.
Are you giving me the value of resistivity or resistance?
Resistance.
Resistance, it is given as 500 ohms. 4 into 10 power 5 into 25 into 10 power minus 2 plus 5 into 10 power minus 5 into 70 into 10 power minus 2, that is in the numerator, divided by 9 into 10 power minus 6. How much did you get? You get actually 1 by 2 into 1000. 1000 by 2 you are getting. Check. I don't know whether there's a mistake anything here. See, 4 into 25, that gives you 100. 100 into 10 power minus 7. 100 into 10 power minus 7. Okay, maybe the answer here is wrong. Just check whether you're getting resistance as 500 ohms. They have given us 4.5 into 10 power minus 3 divided by 9 into 10 power minus 6. You're getting 500. Ohms. So you got the resistance R as 500 ohms. That will be written as common rho L by A. You have to calculate rho. What will be the common length, total length? 70 plus 25. Take the whole length. So from that value, once you get the resistance 500 ohms, you can write R is equal to rho L by A, where L is the total length and area of cross section, that is same, common. Calculate rho. But rho answer is not given here. So we'll go for the next one. Resistance you got? Sri Varshita, you got 500 ohms. Laya, Shaktivel. Laya, you got? Laya Shri, Pavitra. Now, next question. 3 identical lamps, each having a resistance R, are connected. Yes, Pratap.
Oh, sorry. Unmuted by accident.
Okay. 3 identical lamps, each having a resistance R, are connected to a battery of EMF as shown in the diagram. Now note the diagram. There is a common cell here which is connected to 3 bulbs, each having resistance R, and there is a switch in between. Now, suddenly the switch is closed. Calculate the current in the circuit when S is open and when S is closed. What happens to the intensity of the bulbs A, B and C in both the cases? That is when the switch S is open and when the switch S is closed. Now, when the switch is open, all the 3 resistors are in series or parallel? Series. So, what will be the total resistance in the circuit when the switch S is open? The total resistance will be 3R. 3R. So, the current in that case, that is when S is open, the current will be equal to epsilon, whatever they have given, whether they have given V or here they have given as epsilon. So, you can also write the same symbol, epsilon divided by 3R. That will be the current when the switch S is open. Now, what will happen if they close the switch S? This third bulb, see, it will be cut off from the circuit. That will not have any separate EMF. As a result, it will stop glowing. The current will always take the shortest path. It will not try to take a loop in which there is no EMF at all. So this becomes isolated. C will be out of the circuit, and as a result, the resistance of the circuit reduces to 2R. First it was 3R, now it becomes 2R. Now what will be the new current? When the switch S is closed, epsilon divided by 2R. So write down. Calculate the current in the circuit when S is open and S is closed. Now what will happen to the intensities of the bulb A, B and C? In first case, When S is open, all the three will glow with the same intensity. All the three has got same resistance, same potential drop, and the same current is flowing through all the three. So the intensity of the bulb will be same for A, B and C in case 1 when the switch S is open. Now what will happen when you close the switch S? Because the resistance has reduced, what will happen to the current? The current in the circuit increases or decreases? Increases. Resistance has decreased, so the current value increases. So the intensity of A and B increases. They glow brighter than the previous case. And C will not glow at all because there is no current through C. So write down the answer. Also calculate the voltage drop across the three bulbs when S is open and when S is closed. The voltage will be equally divided between the three bulbs in case 1 because all have the same resistance. So V will be equal to V by 3 in all the three cases, or epsilon by 3. They have given as epsilon. So what have then? That is when S is open, and if S is closed, the voltage increases by, it will be half, V by 2, V by 2 in both the cases. Calculate the power delivered to the circuit when S is open and S is closed. Power formula, V into I. Yeah. Write everything and tell me the answer. So in case 1, you have all the three resistance in the circuit. The total resistance will be 3R when S is open, and when S is closed, the resistance reduces to 2R. Calculate the current, what will happen to the intensity, what will be the voltage, and finally calculate the power. So all the bulbs will glow with same intensity. And in this case, what will happen? A and B glow brighter. C does not glow. Power will be epsilon square by 9R. In this case, epsilon square by 9R. And in this case, it will be epsilon square by 4R. You have to multiply the current and voltage. You will get the power. Power consumed by the third bulb will be 0 in this case. Clear? Got the answer?
No, I can show it again.
You want the answer or the question?
Answer me.
Yes. And power, I told you.
Okay.
Yes. Now, the current through an element is as shown in the diagram. Determine the total charge that passes through the element at time t is equal to 0, t is equal to 2 seconds, and t is equal to 5 seconds. They have given you the current. How to calculate the charge, total charge, I into t. Now, at t is equal to 0, what is the value of I? I is 10 ampere. I is equal to Q by T. So Q is equal to I into T. Time is 0. So charges will not flow at all. Then second case, I is equal to, what is the value of I? 5. 5 ampere for a time t is equal to 2 seconds. So Q is equal to I into T. 5 into 2, 10 coulombs. And then third case, t is equal to 5 seconds. I is equal to 0. So Q is equal to 0. So first case 0 coulomb, second case 10 coulombs, and third case 0 coulomb. You want to copy? Anybody? Shall we go for the next question? Now, an electronic hobbyist is building a radio which requires 150 ohms in her circuit, but she has only 220, 79, and 92 ohm resistors. How can she connect the available resistors to get the desired value? You can try with series and parallel. The total answer should be 150. And the given resistors are 220, 79, and 92. Try parallel and series combination. Which resistors are to be connected in series and which resistors are to be connected in parallel? Pratap, you tried?
Time.
Ivan, Harvish, you got the answer? 220 and 79 you tried parallel. எவ்வளவு வந்தது total? When you connect 220 and 79 in parallel, how much do you get? 1 by 220 plus 1 by 79. 79. அது ரெண்டையும் parallel try பண்ண 1 by 220 92 தனியா இருக்கட்டும், இது ரெண்டு மட்டும் அதை சீரீஸ்ல போட்டுக்கலாம். 150 தாண்டி போகாது, parallel போட்டா குறைஞ்சிடும் இல்லையா? 200 220 92 parallel போடக்கூடாது. 220 150 வராது. செக் 58 தான் வரும். You got
79 and 92 series இருக்கும். அந்த addition and 220 parallel.
This two if you add, how much are you getting?
79 and 92.
92 add பண்ணும்போது 171. Okay, 171 parallel to 220 எவ்வளவு வந்தது? You didn't check. Actually 220 79 parallel ல போடணும். அது parallel போட்டா exactா 58 வரும். Try 1 by 220 plus 1 by 79 cross multiply பண்ணி exactly you are getting 58. 79
try பண்றேன், ஆனா value plus
இல்ல 58 வருது exactly. Numerator வந்து 220 into 79 reciprocal பண்றோமா? So reciprocal பண்ணும்போது 220 into 79 divided by 299 வரும். Exactly you are getting 58. See, actually 220 and 79 should be put in parallel and check whether you are getting 58. Exactly 58 you are getting. That 58 when added to 92 you get 150. Just check whether you are getting. Yes ma, Pratap.
Got the answer, ma'am.
Yes.
220 and 79 in parallel.
Yes, 220 and 79 in parallel. So 1 by R and 92 is in series with this parallel combination. Now next question, 9th one. A cell supplies a current of 0.9 ampere through a 2 ohms external resistor and a current of 0.3 amps through another external resistor 7 ohms. Calculate the internal resistance of the cell. What is the formula for internal resistance? Small r is equal to epsilon minus V by R. V by I, right? R is equal to V by I. So the current that is flowing through the circuit. So epsilon minus I into external resistance divided by I. So find the internal resistance in both the cases. I think you should get the same answer. Two values they have given, no? Epsilon will be same and internal resistance will also not change. I1 R1 by I1 will be equal to epsilon minus I2 R2 by I2. Now these two values will be same. The internal resistance will be same in both the cases. How will you solve from these two? Subtract these two equations. I1 minus I2 into R is equal to I2 R2 minus I1 R1. Now substitute and calculate the value of small r. You can take the larger value as I1 and the smaller value as I2. So you know the values of I1, I2, R1, R2. Calculate small r. The cell supplies a current of 0.9 ampere through a resistor 2 ohms and a current of 0.3 ampere through a resistor 7 ohms. Calculate the internal resistance of the cell. Noted the values. Ninth one. Zero point five.
I'm getting 0.5 ohm.
Yes, 0.5 ohms. Got the answer, all of you? Now next one, calculate the currents in the following circuit. That is, you have to calculate I1, I2.
Ma'am, can you show the previous calculation, ma'am?
Yes.
I'm completed, ma'am.
Yes. Now take any loop and calculate the value of I1, I2 and I3. You can choose any loop. Calculate the currents in the circuit. You can choose either this loop or the bigger one or this loop also. Form equations and then solve I1, I2 and I3. You can choose any loop of your. Choose any loop, nickel. R3 100 ohms. R3 la pora current வந்து I2. I2 is the current passing through R3. I1. I1 0. No. If you are choosing this loop, what will be your equation? This first loop, 100 I1 plus 100 I3 is equal to 15. 100 I1 plus 100 I3 is equal to 15. That is one equation. Then any other loop? I1 plus 100 I2 will be equal to 15 minus 9, 6 volt. If you are taking this bigger loop, it will be 100 I2 plus 100 I1 is equal to 15 minus 9, 6 volt. That is second equation. Then I1 is equal to I2 plus I3. I1 splits as I2 plus I3. So wherever you have I1, you can reduce it to I2 plus I3. Then you will get two equations in two variables. You can easily solve. First equation you had 100 I1 plus 100 I3 is equal to 15. Second one is 100 I1 plus 100 I2 is equal to 6. But I1 is equal to I2 plus I3. Then you will get two equations, two variables, solve I2 and I3. Once you know I2 and I3, you can add and find out I1. Pratap, what equations did you get? Solved, huh? Trying to solve?
Yes, ma'am.
Dishita, Shaktivel, you got the equations? Ivan, Laya, Navina, Pavitra, Saravanan, Nitish.
is not visible, ma'am.
Question, you want the question? Diagram? Or you want the answer? You want the circuit diagram, Saravanan?
Circuit diagram, answer, ma'am, circuit diagram.
Use cross multiplication method or anything. Solve I2 and I3.
Ma'am,
Yes, ma.
one is 0.07 ampere.
I1 now. 0.07 ampere, correct. I1 is 0.07. Then I3, I2, 0.08. I2 is minus 0.10. Finished? Okay, next question. A potentiometer wire has a length of 4 meters and a resistance of 20 ohms. It is connected in series with a resistance of 2980 ohms and a cell of EMF 4 volt. Calculate the potential along the wire. What is the equation for potential? Potential V is equal to, according to Ohm's law, V is equal to I into R, the total resistance. Now how to calculate I? I is equal to epsilon divided by whatever resistance you have in the circuit. So write down V is equal to I into R. V is equal to I into R. They have calculated the potential across the wire, which means for R you have to take 20. V is equal to I into R, that R will be 20. Now how to calculate I? I is equal to the total EMF supplied divided by the two resistance in series. One is for the potentiometer, the other one is the external resistance that you have connected. Okay, here you have to use RP. Now substitute and find out. Epsilon, what is the EMF of the cell? 4 volt. Resistance of the potentiometer is 20. Here it is 2800 and 2980 plus 20. They have actually asked potential gradient. Potential gradient is written as dV by dx or dl, length. So you will get the potential from here, that you have to divide by the length of the potentiometer wire, which is given as 4 meters in the question. First calculate the potential difference, then divide it by 4 meter. Then you will get the potential gradient. Calculate the potential divided by the total length of the potentiometer.
It is 0.006.
0.6 into 10.
0.006.
0.006. Yeah, 0.6 into 10 power minus 2. So 0.006. Yeah, correct. Volt per meter. Finished, all of you?
0.6 into 10 to the power minus 2 volt per meter.
Yes, minus 2 volt per meter. Now next one, determine the current flowing through the galvanometer shown in the diagram. Ig you have to calculate. Calculate Ig. calculate IG. The bridge is not balanced, so IG will not be 0. In the 5 by 15 and 10 by 20, the ratio is not same. The bridge is not balanced, so you will have a value for IG. Tell me any three equations. Choose any loop. Suppose you choose PQSP. PQSP. Tell me the equation. 5I1. Tell me 5I1 plus 10IG minus 15I2 is equal to 0. Write down. 5I1 plus 10IG minus 15I2 is equal to 0. Yeah, 5I1. You have copied the diagram, circuit diagram, all of you? So you're taking the loop PQSP. From the diagram, tell me. 5I1 plus 10IG minus 15I2 is equal to 0. Now take the loop QRSQ. Tell me. QRSQ. 10 into I1 minus IG minus 20 I2 plus IG minus 10 IG equal to 0. So multiplying inside, what do you get? 10 I1 minus 10 IG minus 20 I2 minus 20 IG. IG is equal to 0. So this becomes 10 I1 minus 20 I2 minus 40 IG equal to 0. Equation number 2. Copy down. Yes. Then try PQRSP. PQRSP. Try to form the equation PQRSP. PQRSP. அதுதான் சர்க்யூட் டயக்ராம் வரைஞ்சிட்டியான்னு கேட்டேன். 5, 10, 15, 20, I1, I1 minus IG, I2, I2 plus IG. இது மட்டும் நோட் பண்ணிக்கோ. 5, 15, 10 and 20. Here also, galvanometer has a resistance of 10 ohms. Now, can anybody tell me PQRSP? 15, 5, okay, 15 I1 minus 30 IG minus 35 I2 is equal to 0. So 3 unknowns, 3 equations. Solve. Tell me, you get 5 I1 plus 10 into I1 minus IG minus 20 into I2 plus IG minus 15 into I2. So 3 equations, 3 unknowns. Solve fast. That's an unknown. IG is not 0. I told you it is not that. Pratyunjay, are you trying? 1 by 11. 1 by 11, 0.99 almost. 0.88 varga. Roughly it should be 1 by 11. IG will be equal to 1 by 11. So now for the last question. Yes. 1 by 11.
0.989.
Yes, 0.999. Correct. 1 by 11. Now, this is the last question. Draw the circuit diagram for this first. All of you draw the circuit diagram. There are two cells, each having 5 volt. It's connected in series. across a 8 ohm resistor. Okay, it is in series to an 8 ohm resistor and 3 parallel resistors 4, 6 and 12. Draw the circuit diagram. You have to draw 2 cells each having 5 volt. That should be in series with an 8 ohm resistor. The whole thing, the whole 5 that is 2 cells along with that 8 resistor, it should be parallel to. There are 3 resistors in parallel, 4, 6 and 12. Draw a circuit diagram and calculate the current in each resistor. First you draw the circuit diagram. Show this 4, 6 and 12 in parallel. Along with that parallel connection, draw a series of 8 ohm resistors. Then 2 cells each having 5 volt. Very easy. Draw the circuit diagram. Now calculate the current in each resistor, that is 8 ohms, 4, 6 and 12. You have to calculate the current across all the 4 resistors, that is 4, 6, 8 and 12 separately. Finish drawing the diagram. This whole parallel should be in series with 8 ohms. Now 8 is also become parallel. So 4, 6 and 12 are in parallel. 4, 6 and 12 ohms are in parallel to an 8 ohm resistor which is connected in series to 2 cells. So this will be your circuit diagram. What is the total resistance? Total current I is equal to the total volt divided by the total resistance. Find the total resistance. 1 ampere. You got I is 1 ampere. So what will be, what have they asked? Current. So current across 8 ohms will be 1 ampere, the total current. What about 4, 6 and 12? So for the parallel connection, 1 by 4 plus 1 by 6 plus 1 by 12. 6 by 12 or 12 by 6. So 2 ohms. That is in series to 8 ohms. So 8 plus 2, 10. So 10 by 10, 1 ampere you will get. Now this 1 ampere will split into 3. I1. Now what will be the total voltage across, voltage drop across this one? 8 ohms. What will be the voltage drop across this 8 ohm resistance? In the 10 volt in the circuit, eppadi split agum? Idukku one portion of the potential difference you will get. Idukku another portion. In the portion another தெரிஞ்சதுனா you can calculate what will be the potential across this particular combination. So here potential drop will be equal to V will be equal to I into R, which is 1 into 8. This alone will take 8 volt from the battery. The battery is supplying 10 volt. Adla 8 volt idu thaniya eduthirum. So how much will be left over for this parallel connection? Only 2 volt. Clear? அப்படி பார்த்தாலும் இப்போ this is 2 and this is 8. அந்த ரேஷியோல தான் இந்த 10 volt split ஆகும். இந்த full combinationக்கு what was the answer? 2 ohms. So எதுக்கு ரெசிஸ்டன்ஸ் கம்மியோ அங்க பொட்டன்ஷியல் டிஃபரன்ஸ் கம்மியா தான் இருக்கும். கொடுத்த 10 எந்த ரேஷியோல ஸ்ப்ளிட் பண்ணும்? 2 and 8ங்கற ரேஷியோல ஸ்ப்ளிட் பண்ணும். So the whole arrangement will get 2 volt. And இதுல current என்னவா இருக்கும்? This one I will be equal to V by R. That is 2 by 4. இந்த branchக்கு 2 by 4, இந்த branchக்கு 2 by 6, இந்த branchக்கு 2 by 12. 0.5, 0.3, 0.17. And if you add, you will get 1 ampere. 0.3, 0.33, sorry, 0.5, 0.33, 0.17. If you add, again you will get 1 ampere, which is the total current flowing through the circuit. Clear? One more circuit diagram I'll give you. Current கண்டுபிடிக்கிறதுக்கு. Still you have 10 minutes to go. Last, ஒரே ஒரு circuit diagram தரவா? Find the total current. Find the value of current in the circuit. All the three resistors are 30 ohms. Calculate fast. This 30 and 30 are in series. The total answer is in parallel to the next 30. So total resistance kandupidi 0.01. You have any doubts? Anybody over there? Any doubts, ma? Ivan, Saravanan, Pavitra, Navina, Laya, Varshita, Shri, Shaktivel, Anshul. Yeah, thank you, ma. Thank you, all of you. Ivan, any doubts? Ivan?
Sorry, I forgot to read.
Okay.